Hi everyone, welcome. Right now we're doing the arc functions part 6 examples. Right now in front of us we have this example of an integral of 1 over 36x squared minus 36 plus 18. And notice that this integral doesn't really factor with real numbers. And whenever this is the case, one of the best methods we can apply to evaluate this integral is using an arctan substitution. So let's see, the first step that we want to do here is simplify the polynomial itself, therefore by factoring the first element. And for us, the first element is 36, which is the coefficient of the leading element. So let's see. So the first step we do is factor out 36. This would be then 36 times x squared minus x plus a half. So what does this look like? This looks a lot like a square polynomial to me. And what we can do now is, before we actually try to apply the trig sub, and recall the trig sub with arctan, we require something of a form of something squared plus 1. And how do we get that? Well, we can actually complete the square. How do we complete the square? The square have the form, if you have, let's say, a plus b squared, that's going to be a squared plus 2ab plus b squared. And let's see how we can do this in this part of the polynomial. It looks to me the first coefficient is going to be x, whereas the second element should be something of about a half. So let's see how this works out. So this can go in an integral. We have the fraction. We have our factor 36 from the previous step. And so we're going to have, because we have the minus sign here, that means that our first element x, then we have the minus sign. We know x is the first element, and the second element, when you expand the square, is going to be multiplied times 2. So this has to be 1 half squared. And let's see quickly what this expands to. Let me do a different marker. So this expands to x squared minus x plus 1 over 4. So what is missing from this equation to complete the ones that we have right in front of us? Well, we're missing a quarter. So we need to add 1/4 right over here, and let me make this more explicit. Just the brackets go right here and dx. Now let's follow us to the next step. The next step we want to do, we want to make the second element, exactly this element you see here, the quarter, the second one, we want to make it a 1, because that's how we complete the tangent when we do the further trig sub. To make it a 1, we have to multiply times 4. And therefore we're multiplying the first one times 4 as well, and all we have left is a 9. So this would be, let's see, this would be an integral of 1 over 9. So this is the factor 36, but divided by 4, times the fraction of x minus half squared plus 1. And this is a 4. Here's just the brackets for readability. Okay, so let's see what we can do next here. Now, we actually do have something of a form of something squared plus 1. So this is, and 4, as we know, is also 2 squared. So let us say that tangent of a theta is going to equal to 2 times x minus a half. So therefore the tangent squared would be our first element right here. When we do the substitution, let's see what happens here. We have 1 over 9, so the starting coefficient we carried over from factor 36, times, for brackets we're opening up. So this, as we said, is going to be tangent squared theta plus 1. Okay, so but what about the actual infinitesimal dx here? Well, we can actually try to find the derivative of, let's see, so this would be dx, well, tangent, this would be 2x, therefore, oops, sorry, tangent, our original one minus 1, 2 dx. What is this going to be? Well, if we remember correctly, the derivative of tangent is going to be the secant squared. So this would be secant squared theta d theta equals to 2 times x minus a half. It's 2x minus 1. And the derivative of 2x minus 1 is just 2 dx. Therefore, we have that dx is going to be equal to secant squared theta d theta divided by 2. And we can just plug in right back in here. So this would be times secant squared theta divided by 2 d theta. Sorry, this should be a region just like this. And if we remember our trig identities, we also know that tangent squared plus 1 equals to secant squared. And we can see how nicely this simplifies leads us to the solution of this problem. So therefore we have our old carried over coefficient 1 over 9, 1 over secant squared, which came from tangent squared plus 1 equals secant squared, times the expansion of dx that we did using the d theta, which was secant squared theta divided by 2 times d theta. Because everything is multiplied together, we can easily cancel out the secant squared right here, so secant squareds can cancel out. The 2 and the 9 coefficients, they stay on, so this would be 1 over 18 d theta. This is just a scalar coefficient now, so it's going to be 1/18 theta. And if we remember exactly, so what is...
Plus C.
Oh, plus c, exactly. I got... never forget your constant coefficients. So now we would want to go back into our original variable, which was x and not theta. So what is theta? Well, theta is going to be the arctangent of 2 times x minus a half. So this is going to be, only if I had the space, so this would be 1 over 18 arctan of 2x minus 1 plus c. Thank you so much. Hope you enjoyed this problem.